All right, let's talk about this review problem. We have somebody that is saving for retirement. The recurrence relation for the amount of money in the retirement account follows a sub n equals 1.002 times a sub n minus 1 plus 105, and a sub 0 is equal to 300. Now, what are the significance of these numbers? 300 would be the amount of money that the teacher starts with at time 0. The teacher places an extra $105 in per month, and the 1.002 represents the interest per month. So it's 0.2% interest per month is the interest rate monthly. So if we multiply the previous amount by 1.002, that would give the new amount. How much money will be in the account when she retires after 35 years? So this is a recurrence relation. I'll write it in the form a sub n minus 1.002 times a sub n minus 1 equals 105. So this is a non-homogeneous first order linear recurrence relation. And so to get started, we'll look at the homogeneous equation first. So h sub n minus 1.002 times h sub n minus 1 equals 0. So the characteristic equation would be r minus 1.002 equals 0. And clearly the solution for this is r equals 1.002. And so therefore the solution of the homogeneous equation is going to be a constant times 1.002 to the n, for a constant to be determined later. Next thing we need to do is find out a particular solution. So p sub n minus 1.002 times p sub n minus 1 equals the constant 105. And so our rule is that if we have a constant on the right-hand side, let's try p sub n equals a constant that does not depend on n. So we have constant minus 1.002 times the same constant, because it doesn't depend on the index, equals 105. And so minus 0.002 times x equals 105. And solving for k, we find that k is equal to negative 52,500. So the next step is we find the general solution by adding these two together. And so our a sub n is going to be equal to c times 1.002 to the n minus 52,500. Now we still have the one unknown constant c that we need to find. And the way that we find that, we go back to the initial condition here, a sub 0 is equal to 300. So I will plug in n equals 0, and we get that is supposed to be equal to 300. And if I plug in 0 on the right-hand side, we get c minus 52,500. So solving for c, we get that c is equal to 52,800. So in conclusion, we see that a sub n is equal to 52,800 minus, or so 52,800 times 1.002 to the n minus 52,500. All right, we're almost done. The question asked how much money will be in the account when she retires after 35 years. So to find the amount of money that she has after 35 years, we remember that 35 years, n is measured in months, so 35 times 12 is 420. And so we figure out a sub 420, the 420th term of this series, of the sequence, pardon me. So we plug in 420 and see what we get, and the answer is $69,701.62 by plugging in 420 in for n. And so that's the amount of money that she has at retirement. Now this is a good problem for just real life. So I made up these numbers in this problem, but by changing the amount of money at the start, by changing the amount of money that gets saved every month, and by changing the interest rate, this is something that you can do for yourself for predicting how big your nest egg will be when you retire.